Yep. It's going to record. Here we go. So this topic, let me know if you can read it. I brought just a normal pen. Is section what? 1.4 in our book. Can you see it, everyone? Exponents. We're going to talk about the properties or the laws of exponents. But first thing first, when you see 5 to the power 4, what does that mean? 5 times 5 times 5 times 5. How many times? 4 times. That's 625, I think. When you see 2 to the power of 10, what does that mean? 2 times 2, how many times? 10 times. And if you multiply them out, that's 1,024, I think. I was multiplying correctly in my head there. When you see 3 to the power of 0, what is that? Anyone has a calculator I can borrow for a second? Basic one. I don't want a good one. I want a cheap one, just to show you. 1. Notice. There we go. Turn on. Clear everything. 3 to the power. Where's the power button here? Power button.
Up 1
over the 7. Up 1. Oh yes, thank you. To the 0. Notice it's 1. 3 to the 0 is 1. Why? Because that's one of the rules. It says any number raised to the 0 power is 1 except 0. Any number raised to the 0 power is 1 except 0. If I take this calculator and I write 0 to the 0 power, it's going to give me an error. Can you see that 0 to 0? Hit equal. It says domain error. Can't be done. But any number raised to the 0 power is 1 except 0. Where this could get you in trouble when you see a problem like this. Assuming x is not 0. What is that equal to? 5. Why 5? Why not 0? Correct. So this is the only thing that's raised to the 0 power. Only that piece. So that's a 1. So it's really 5 times the 1, which is what? 5. I like the blue marker better, actually. Maybe I'll stay with it. If I wanted the whole thing, assuming again x is not 0, if I write this 5x to the 0, what's the answer? That's a 1. Now, other properties of exponents is when you have the same base, if you're multiplying, if the base is the same, you keep the base, and what do you do with the exponents? You add them. When you multiply, keep the base. If the base is the same, keep the base and add the exponents. If the base is not the same, not much you can do. So an example here, if I have 2 to the 4th times 2 to the 3rd, that will be 2 to the power 4 plus 3, which is 2 to the 7. I think that's 128. check that on your calculator. I think it's 128. If I have 5 to the 6 times 5 to the negative 3, the base is the same. Keep the base and add the exponent. 6 plus a negative 3, which is what? 5 to the 3, which is 125. There could be decimal numbers. Could be 6 to the power 4.2 times 6 to the power 3.7. This will be 6 to the power of what? 4.2 plus 3.7, and that'll be 6 to the power of what? 7.9. So when you multiply, keep the base, add the exponent. What about when you divide? That's the next rule. You subtract. Keep the base and subtract the exponent. Keep the base and subtract the exponent. So if I have 7 to the 9th over 7 to the 7, this will be 7 to the 9 minus 7. You're going to subtract the exponent. 9 minus 7 is what? Squared. And what's 7 squared? 49. Two to the 3 divided by 2 to the negative 2. Again, subtract the exponents. 2 to what power? 3 minus a negative 2. What's minus a negative 2? And 3 plus 2 is 5. 2 to the power 5, which is what? 32, is it? 2 to the 4 is 16. So you multiply it by one more 2. Here's the problem. Every once in a while we end up in a little sticky situation. We have something like this. 4 to the 3rd, 4 to the 5th. You go, I got it. I know what to do. Subtract the exponents. It's 4 to the power of what? 3 minus 5. What's 3 minus 5? Negative 2. Well, there's a problem with that. There's no math book that I know that likes to see negative exponents. So how do we take that negative exponent and change it to positive? And that's where the other rule comes in. When you have negative exponents, you can rewrite that 1 over a to the n. So if I take that answer now from the top, I say, well, they don't like that answer. They don't like 4 to the minus 2. So what is that equal to? 1 over 4 to what power? Second. What's 4 squared? 116. I'll do one more rule. I don't see it in our book, and that's power to power. Or I'll do a couple of these just to make sure you got the negative exponents. That would be 1 over 5 to the 3rd which is what? 1 over 125. Seven to the minus 1. That's 1 over 7 to the 1. 7 to the 1 is 7. 1, 7. Keep your eyes open on the next one. 5x to the negative 3. 5x to the negative 3. Anyone? Who is raised to the negative 3? X. Only x. So the 5 stays on the top, and this will be 1 over x to the 3. If you want to do them in one step, that'll be what? 5 over x to the third. So the 5 is not raised to the negative 3. That's why it doesn't go on the bottom, it stays on the top. Only the x is raised to the negative 3, and that's why the x drops to the bottom. I didn't see this rule in the book, and that's power to power. I'll put it there anyway. Power to power, you actually multiply. Power to power, you multiply. So now, if I have 2 to the third to the fourth power, I'm going to write that 2 to what power? 3 times 4, which is what? 2 to the 12. That's 3 times, not the point. 3 times 4. If I have 5 to the negative 2 to the third power, power to power, you multiply. That's 5, 2. Negative 2 times 3. What's negative 2 times 3? Negative 6. We don't like negative exponents, so what do? 1 over 5 to the 6. So these are the laws of exponents. I'll do more examples in 1 second here, but I also want to talk about order of operations. Then I'll start doing some problems there. Order of operations. When you have more than one operation, like parentheses, exponents, multiplication, division, addition, subtractions, which one do you do first? Parentheses. Parentheses first. We did, yeah. Which one second? We talked about it last class. Exponents. As I said, the book brings them again. Multiplication and division. Again, when I say multiplication and division, we go left to right. If I see multiplication first, you multiply. If I see division first, I divide. And the last one, what? Addition, subtractions. We went over that last class, but our book decided to bring it back one more time. Again, left to right. Let me try a few examples here with different of the rules here, some with order of operation, some without it. And I'm actually looking in the back of the book. I don't see. The only thing I see is you might have a problem like this. So that's an example they're giving us. So there's really no parentheses. I can't simplify what's inside the parentheses. Minus 1, can I simplify the minus 1? No. Minus 3, can I simplify that? No. So when we say about parentheses, if there's more than one operation inside that, go ahead and simplify it. Here, you can't simplify what's inside the parentheses. So you go to the exponents. And again, left to right. What's negative 1 squared? 1. What's negative 3 squared? 9. So I did the exponents. There was no parentheses. I did the exponents. Do I have any multiplications or divisions? I see one at the end. What's 2 times 9? Yep. Now I only see subtraction. If you have addition, subtractions, you go left to right. What's 8 minus 1? 7. 7 minus the 18. Is it negative 11? That's the only problem our book gives us on this subject, at least for now. We did more last class on them. We did with x's, variables in them and everything. But that's the only one they're giving us there. Let me try to take some big problems from our book there and see if we can simplify that. Negative 8 g to the minus 1, that's a g to the minus 1, s to the 3 power, the whole thing raised to the power of 2. Two ways to look at that problem, two different ways to solve it. One of them, I'll leave a space there. I'll go to the second method. In the second method, it says negative 8 g to the minus 1 s to the 3. When you square it, what are you doing? You're multiplying it by itself. And it doesn't matter how you write them. You're multiplying 3 things by 3 things. So you can rewrite that as negative 8 times the negative 8. Put them next to each other. Put the g's next to each other. Put the s's next to each other. Doesn't matter where you put them. What's negative 8 times the negative 8? 64. G to what power? When you multiply, what do you do with the exponents? You add them. minus 1 plus a minus 1, which is what? Negative 2. And again, s to what power? You add the exponent, which is what? 6. Can you see it? Now, the other space I left there to do them differently. First, by the way, if this is your answer, I'm almost positive they're not going to like the answer with negative g's in it. So right now, that's over 1. Anytime you have a negative exponent, I always say cross the line, change the sign. That's for negative exponents. Cross the line, change the sign. What do I mean by that? I'll wait till you finish writing. Here's g to the minus 2. Negative exponent. If I bring it down, I'm crossing that line. If I cross the line, I gotta change the sign of that exponent. So that becomes what? 64 s to the 6 divided by what? G squared. And that's the answer you want to put there. So let me go back to the first method I had in my mind. I left a space for it because I don't want to do it this way, especially if this is the power of 10. Do I want to sit down and multiply it 10 times? Hell no. So what's negative 8 when you square it? That's 64. G to what power? Power to power you multiply. What's minus 1 times a 2? Negative 2. S to what power? What's 3 times 2? 6. We don't like negative exponents. That's over 1 again. Cross the line, change the sign. 64 s to the 6 over what? G squared. Is that the same answer? Much quicker. So anytime I have negative exponents, I do them actually cross the line, change the sign. I find it a little bit easier and quicker. Let me try another one. Let me try to find something big in our book. And I don't see anything that big there. This is one of the biggest things that I see is like babies. Ax to the power of negative 2 times negative a squared x cubed. I have to do what? I gotta do the power first. If I do the power first, there's a negative. That negative means negative what? Negative 1. So what's negative 1 when you raise it to the power 3? What's negative 1 times a negative 1 times a negative 1? It's negative 1. I can put the 1 or take the 1 out. A to what power? What is 2 times 3? 6. X to what power? What's 1 times 3? 3. And you're going to multiply that by a x to the negative 2. I can reshuffle them. I can put the -1 in the front. I can put the a's next to each other. I can put the x's next to each other. When you're multiplying, 2 times 3 times 4 is the same as 2 times 4 times 3, the same as 4 times 3 times 2. Doesn't matter which one you write first. I don't need to write the 1, that'll be a minus. A to what power? 7, because there's a 1 here, we just don't put it. What's 1 plus 6? 7. X to what power? 1. You add the exponent. -2 plus 3, which is 1. And normally you don't put the 1 there. That's my answer. I'll do one more. Again, power to power, you always multiply. The 4 has a power of 1 right now. This will be 4 to what power? -3. 1 times a -3 is -3. X to what power? What's -1 times a -3? +3. And A to what power? What's -1 times -3? That's 3. I don't like negative exponent. Cross the line, change the sign. Take that negative exponent, bring it down here. That's the only thing that has negative exponents. What's 4 cubed? 4 times 4 times 4, which is what? 164? I mean, just 64, not 1. 64. And that's my answer.